This is why you need to know about environmental instruments. Our environment is changing every day. But how do scientists collect data about it? Let's explore the most important environmental instruments and how they work. Thermometer measures air and water temperature.
Thermometer, why we use it and how it works. We use a thermometer because it's basically our go-to device for measuring temperature, how hot or cold something is. Its principle is pretty simple. It has a sensor that responds to temperature changes. For example, in a mercury thermometer, the mercury expands or contracts as the temperature changes, and that movement shows you the temperature on a scale. In an infrared thermometer, it's a sensor that detects infrared energy and converts it into a temperature reading. So that's why and how we use it, basically to know how warm or cold things are in a reliable way. Now move to the next slide. We have two common temperature scales, Fahrenheit, because different regions historically adopted different standards. The Celsius scale is based on the freezing and boiling points of water, 0 degrees C for freezing, 100 degrees C for boiling, while Fahrenheit uses a different scale, 32 degrees C for freezing, 212 degrees C for boiling. They'll both measure the same thing, just with different numbers. To convert between them, we use simple formulas. From Fahrenheit to Celsius, subtract 32 from the Fahrenheit value, multiply by 5 and divide by 9. From Celsius to Fahrenheit, multiply the Celsius value by 9, divided by 5, and then add 32. And that's how you flip temperatures back and forth between the two scales.
Anemometer tracks wind speed and direction. Rain gauge records rainfall. Barometer checks air pressure. Hygrometer measures humidity. Together, these tools predict weather and climate trends. Gas analyzers detect harmful gases like CO, NOx, and ozone. Particulate samplers measure dust and fine particles. These protect public health by monitoring pollution. Soil moisture sensors show how much water soil holds.
So basically, the idea is that a master sensor is like the main brain of a smart irrigation setup. It's super important because it helps all the other sensors, like soil moisture sensors, talk to each other and to your irrigation system. When you have that kind of connectivity, the whole system can adjust watering schedules automatically. It's like having a smart assistant for your crops that knows exactly when and how much to water. A lot of companies use these master sensors in their smart irrigation systems, companies like Netafim, CropX, Valley Irrigation, and so on. They all integrate these sensors to make irrigation as efficient and water saving as possible. In short, smart irrigation is the best way to ensure your plants get exactly what they need without wasting water. It's a win-win for both your crops and the environment.
Water is one of the most important resources in farming, and today, we'll explore how smart irrigation systems are transforming the way we grow food. Join us as we dive into the world of water-saving irrigation technology that boosts yields and reduces water waste. Imagine watering your crops with pinpoint accuracy, ensuring every drop counts while reducing water usage by up to 60%. With smart irrigation systems, that's not just possible, it's happening today. Stay with us to learn how precision irrigation can help you save water and increase your farm's productivity. What are smart irrigation systems? So, what exactly are smart irrigation systems? These advanced systems use real-time data from weather stations, soil moisture sensors, and other monitoring tools to optimize the amount of water applied to crops. Traditional irrigation methods like flood irrigation or overhead sprinklers can waste a lot of water through evaporation and runoff. In contrast, smart irrigation systems adjust water usage based on the specific needs of the crop and environmental conditions. For example, if the soil sensors detect that the moisture levels are sufficient, the system will reduce or pause irrigation, preventing overwatering. These systems can be automated and controlled remotely via a smartphone or computer, allowing farmers to monitor their fields and adjust irrigation schedules from anywhere. This irrigation technology not only conserves water but also improves crop health by ensuring plants get the right amount of moisture at the right time. The benefits of water-saving irrigation. One of the biggest advantages of smart irrigation systems is their ability to conserve water. In regions where water is scarce or expensive, saving water is crucial for both economic and environmental reasons. By using precision irrigation techniques, farmers can reduce water usage by up to 60%, depending on the crop and climate. But the benefits don't stop there. Smart irrigation also helps boost crop yields. When plants receive consistent and accurate amounts of water, they grow stronger, healthier, and produce more. This technology reduces the stress on crops caused by inconsistent watering, which can lead to issues like overwatering or drought stress. Additionally, smart irrigation systems minimize water runoff and nutrient leaching, keeping the soil fertile and preventing water contamination. It's a win-win. You save water, reduce costs, and get better crop outcomes. Precision irrigation and real-time monitoring. One of the key features of smart irrigation systems is their ability to provide real-time monitoring and control. These systems rely on precision irrigation technology, which uses data from sensors to make instant adjustments to water flow. For example, if a weather station detects an incoming rainstorm, the system can automatically pause irrigation to prevent overwatering. Similarly, if the soil moisture sensors indicate that one area of the field is drier than another, the system can direct more water to that specific spot. Farmers can monitor all of this data on a single dashboard, whether they're at home, in the field, or even miles away. This level of control not only ensures that crops get the exact amount of water they need but also allows farmers to make adjustments without wasting time or resources. By optimizing water use down to the individual plant level, farming irrigation solutions are driving greater efficiency and sustainability in agriculture. Case study: how smart irrigation is boosting yields. To see just how effective smart irrigation systems can be, let's take a look at a case study. In California, a vineyard implemented a smart irrigation system to address water shortages during the dry season. By installing soil moisture sensors throughout the vineyard and integrating them with an automated drip irrigation system, the farm was able to reduce water use by 45%. Not only did this cut water costs significantly, but the vineyard also saw a 20% increase in grape yield. The system's real-time monitoring ensured that each row of vines received the exact amount of water needed, which reduced stress on the plants and improved overall fruit quality. This is just one example of how irrigation technology can make a tangible difference in farming operations, especially in regions where water conservation is critical. Whether it's a vineyard, orchard, or row crops, farming irrigation solutions are helping farms achieve better results while using fewer resources.
Soil pH meters test acidity or alkalinity. Tensiometers measure water tension in soil. Farmers use them for better crop growth and land management. pH meters check water acidity. Dissolved oxygen meters tell if water supports aquatic life. Turbidity meters measure clarity. Conductivity meters detect dissolved salts. These ensure water is safe for ecosystems and people. Satellites and drones scan large areas for environmental changes. GIS maps track forests, land use, and pollution. They give us the big picture of Earth's health. Environmental instruments are the eyes and ears of science. They measure air, water, soil, and climate, helping us protect our planet. Like this video if you care about the environment, and subscribe for more learning content.